Still on part 5, let's do another problem, exam question. In this triangle, in this figure, angle B is equals to 90 degrees, as you can see there. We are told that BC is equals to 3 times AB. BC is 3 times AB, and BS, which is BS, is 2 times AB. AB is produced, as you can see, AB is produced to T such that BT is equals to 4 times AB. So this is 4 times that, this is 3 times that, this is 2 times that. Now, we are told to prove that AC squared is equals to 2 times AS squared. This, we have to prove that this is 2 times, this squared is 2 times this squared. Now, for us to do that, we can first find AS. Let's find AS. We know that this is AB. We know that this is 2 times AB. Therefore, we can find AS. Let's find AS. AS squared, which is the hypotenuse, the longest side, is going to be equals to this, which is equals to AB squared, plus is also going to be equals to that, which is BS is 2AB. 2AB all squared. Now, this becomes AB squared plus 4AB squared. These are like terms. We can add them. 5AB squared, which is your AS squared. Now we can find AC squared. There's your AC, which is your hypotenuse. AC squared is equals to, obviously going to be equals to that squared plus, we know that, which is BC, and we're given that BC is equals to 3AB all squared, which is equals to. Now this becomes AB squared. This becomes plus 9AB squared. These are like terms. We can add them. 10AB squared. Now we can write this as 2 times 5AB squared. We know what is 5AB squared. There is our 5AB squared, which is equals to AS squared. Therefore, AC squared is equals to 2 times, we know what's that, which is AS squared. Therefore, we have proved that AC squared is equals to 2 times AS squared. Now, B. We are told to triangle AST, we must prove that triangle AST, this triangle, we must prove that this triangle is a right-angled, We must prove that it is right-angled, and for us to prove that this triangle is right-angled, it means that we can prove that this triangle is right-angled there. We can prove that it is right-angled there. And how do we do that? We do have AS squared, which is that. We must find this side, which is ST. Once we get this side squared plus this side squared and get that, then we have proved that this is right-angled. Let's see that. Now, For us to prove that this is a right angle triangle, we must first find this side there. We do have this side. When we add this side and this side all squared, we must get, once when we get this all squared and this all plus that all squared to be equals to that, then we know that this is right there. Now, for us to do that, we must first find ST. We do have this, we also have that BT, because BT was given that it is 4AB. Therefore, we do have BS, and BS is equals to 2AB. Now we can find ST squared. ST squared is equals to BT squared plus BS all squared. Now, BT, we know that it is 4AB all squared plus BS, we know BS, where is it? There is your BS. The BS is 2AB all squared. Now, this becomes 16AB squared, this plus 4AB squared, which ST squared is equals to 20, because this plus that is 20 AB squared. We know ST that it is 20 AB squared. We do know that, therefore, AT is equals to AT squared. Is going to be equals to this squared plus that squared, which is 20 AB squared. Obviously, we've just said it, that this will be this squared plus that squared, which is, that is AS, or AS, where's our AS? AS there, it's 5AB squared, which is equals to, this is the same as 25AB squared. But now, we have used Pythagoras to get AB. This and that, this all squared plus that all squared must give us that all squared. Now, let's look at this. AB, if I have AT is equals to AB plus BT. AB plus what is BT? Oh, BT is 4AB, which is equals to 5AB. Now, if I can square that AT, I can also square that, where I have AT squared is equals to 25AB squared, which this is equals to that there. We first got this side, then we used Pythagoras theorem, this squared plus this squared, we got that, which is 25AB squared. Now, to show that this, since it is Pythagoras, we know this length, that this is AB. We know that this is 4AB. Therefore, if I add this and this, I get AT squared. Oh, AT squared is equals to AB plus BT. We add the two. We get, then I want AT squared. AT squared is equals to 25AB squared. which is equals to AT squared when we used Pythagoras theorem. Therefore, triangle AST is a right angled triangle. And we can conclude to say it is right angled at S, at angle S, because this is the longest side, which is equals to that all squared plus that all squared, which is equals to the hypotenuse. And the hypotenuse, we could get it by just adding this and square it to get the same thing that we have got there. Therefore, B, we have proved that it is right angled. Now, C, they say that we must prove that AS squared is equals to AB dot AT. Now, we know when we have something of this kind, we need to prove similarity. We need to prove, since I've got AS, there's my AS, I've got AB, there's my AB, I've got AT. Oh, so it means that I'm going to prove that this triangle and this triangle and this triangle are similar. I repeat that. I'm going to prove that this triangle and this triangle are similar because I've got AS squared, okay? I don't mind about squared, but I have AS. I also have AB. Oh, so I can see AB is in this triangle. I have AT. I can see that AT is in this triangle. So it means that I must prove that this triangle is similar to this triangle. Once I have proved that this triangle is similar to this triangle, then I can set up my ratio, then get that. Let's do that. I remove here. Now, in this triangle and this triangle, in triangle ABS and triangle AST, in this triangle and this triangle, angle B is equals to angle S. Are we there? We know that we are given that, or proved, or given, or both equals to 90. Both equals to 90 degrees. Now, S angle AB is equals to S angle AB, common. I'm just going to remove here. I still get confused. Therefore, this angle, it's an angle for this triangle. It's also an angle for this triangle. Therefore, it is a common angle for both triangles. That is why S angle AB is equals to S angle AB, which is common. Now, we have shown that this is equals to that. This is equals to that angle here. Now, obviously, we know that this angle here is going to be equals to that angle there. We are definitely sure of that because that's your third angle of a triangle. Therefore, obviously, if this is equals to that and this is equals to that, the last two angles, the last corresponding angles must be equal, which is this angle is equals to that angle. Therefore, A angle SB is equals to S angle TB. A angle SB is equals to S angle TB. Even if we didn't do that, because we know that when there's two angles in one triangle, which are equals to two angles in another triangle, like these two, then we know that from here we can conclude that the two are similar, since two angles on one triangle equals to two angles on another triangle. We could have concluded from here, but we're saying that since we also want to prove that, then we can show again which angle is equals to which angle in another triangle. As A angle SB, A angle SB, which is this angle, is equals to that angle. It's going to help us to prove that as well. Therefore, the reason why we're saying that, we say that angle of a triangle. Therefore, triangle ABS is similar to triangle AST. Once we see this, we know we must prove similarity. And once we prove similarity, then we can prove that. Now, I can highlight my angles which are equal. Obviously, this one I'm gonna use red. Okay, it's red, it's fine. Red there, so it means that I'm gonna do a red there. Green there, green there. The last angle, which is the A1, sorry, which is the A1. I'm just gonna make it blue, the A1. But obviously we needed to have another angle, but since it is common, that is why we just have that blue there. Now, let's say AS. AS is opposite this angle and this triangle. Therefore, we write it AS over. We need to find the side which is opposite 90 degrees in this triangle. Because AS is opposite 90 in this triangle, we need a side which is opposite 90 degrees in this triangle. Therefore, AS over, because it's opposite this side 90 degrees in this triangle, it's over AT is equals to, obviously they want AB. AB, which is opposite this angle there. Therefore, obviously, we have studied in this triangle. That is why we said AS, we studied in this triangle, AS over AT is equals to, we need to start in this triangle where this angle, AB, so this angle is opposite this side in this triangle. That is why we say AB over, we look at the side which is opposite this angle and this triangle, which is obviously AS. Now, why is this? Because triangle ABS is similar to triangle AST. That is why we're saying that. Now, this multiplied by that, we cross multiply, we get AS squared is equal to this multiplied by that, it's AB dot AT, which is that there. I think we've done a lot of examples on proving similarity and highlighting our angles for us to set up our ratio so that we can prove what needs to be proved.